Okay, so today we are looking at exploring the domain and range of continuous functions. So, continuous data when can be written and will be written using inequalities. So, either the less than and equal to symbols or strictly the less than symbols. I'm going to write all my blue ones in domain, and I'm going to write all the range values in this purple. Remember domain, remember Dixie. So domain is your input, your x values, or your independent values. And range, roid, so your output, your y values, or your dependent. So when the dots, as you notice with continuous data, the graphs are going to be lines with either an open or a closed dot at either end, or an arrow. But with closed dots, this is when we're using our less than symbol, less than equal to symbols, and then the open dot is our less than symbols. Now, do remember, we don't really use them here, but this is less than or equal to, or greater than or equal to. We just don't really use this when we're writing here, because this number right here, the number that's going to go here, this is going to be our smallest value. And then here, this number is going to be our largest value. So let's look at the domain for problem number one. So problem number one's right here. So here's what I'm going to do. In blue pen, because I'm using domain for blue, I'm going to draw a line that goes straight down here. And I'm going to draw a solid line. And the reason I'm drawing a solid line is because my dot here is filled. So right here, this is -1, -2, -3, -4. This is -5. So for my domain, this is -5, less than or equal to. When I get to here, this is an open dot. So I'm going to go ahead and use dots. So here, it goes through x equals 1. So my domain is -5 less than equal to x less than 1. Because this line uses all of the x values between -5, including -5, all the way up until 1, but not including 1. It uses all of these x values right here. Now for my range. I find the bottom of my graph, and the bottom may not be one of the endpoints. Here, again, I'm making a dotted line because that line is, because that's open, that is not equal to. This one is solid, so I'm going to make a solid line right here at the top. Okay? So my smallest y value all the way down here, that's 1. And that's going to be less than y. And all the way up here, this is 2, 3, 4, 5, 6, 7, 8, 9, it looks like, is less than equal to 9. At any point in time, if you want to move ahead me, that's perfectly fine, because I'd rather have you try these out and make mistakes and then come back and look at the answers than not try them out at all. So I'm looking at problem number 2. Problem number 2, my domain, right over here, this is my farthest that the graph goes to the left, and I'm going to go ahead and make a dotted line because that's an open circle. Right here, this is the farthest it goes to the right, so I'm going to go ahead and make a solid line because that is a closed circle. right here, my smallest x value is -4, less than, because it's a dotted line. My largest x value is 3, and it's included because it's a solid line. For my range, I go to the very bottom of the graph, which is right here. This is the lowest part of the graph. I make a solid line because that's a solid dot. I go to the highest part of my graph, which is right here. I'm going to make a dotted line because that's an open circle. So my lowest y value is -3, less than equal to y, all the way to my top y value, which is 3. So I'm going to skip over problem number 3. I'd like you to go ahead and do that on your own. But problem number 4 is the one I want to talk about. So let's start with our x values. Here's my open circle. I'm going to go ahead and make dotted lines going up and down. And here's my furthest value to the right. It's a solid, so I'm going to make a solid line. So here, my smallest x value is 0, and it's not included, so it's less than x. And then my furthest value to the right is 5, and that is included. Now, range does something a bit different here, and this is why I wanted to highlight problem number 4. My lowest y value is not at an endpoint. My lowest y value is here. So if I have a low value here, this is going to be a solid line through here. The only time I make a dotted line is if I have an open circle. If the graph goes to it like it goes here, or like it does on problem number 5, that's a solid line. And the highest part of my graph, the highest up my graph goes, is right here at this dot. So that's a solid line. So I have 2 solid lines. So that's going to be less than equal to symbols. My lowest y value is -2. My highest y value is 4. So that means all of the values between -2 and 4 are used in this graph. All of these values in here, which they are, from -2 all the way up to 4. So again, I want to practice with problem number 5. Problem number 5, I'm going to do my domain. So domain right here, this is the furthest value goes to the left, and that's a closed dot. This is the furthest value to the right, and that's a closed dot. We have our domain set. So this domain for problem number 5 is -3, less than equal to x, less than equal to 5. Again, with our range here, you find the lowest y value right here, and then you find the highest y value, which happens to be up here. So my lowest y value is -4, less than equal to y, less than equal to all the way up to 3. And so we use all the y values in here within the graph, and we use all the x values from -3 all the way to +5. Verbal, which is going to be a pretty common way to be asked to find the domain and range. It reads, Sam is planning to buy at least 1 pound of chicken for a barbecue he is having, but no more than 4 pounds. The store sells the chicken at $2 a pound. The total cost of the chicken is a function of the number of pounds purchased. So what they're saying with this last part is they're saying the total cost of the chicken is a function of the number of pounds purchased. So this phrasing right here makes that our domain. And the cost of the chicken, that's going to be our range value. because depending on how much chicken you buy, your cost will depend on how much you buy. So that makes the pounds our independent, our input, and our domain. So he plans on buying at least 1 pound. So if he's buying at least 1 pound, he could buy 1 pound. That's the very least that he could. And again, that's our X values for barbecue, but no more than 4 pounds. So he could buy all the way up to 4 pounds, all the way up and including 4 pounds. Now let's figure out our range. And our range for this value, the cost is $2 for every pound. So for 1 pound, that's $2. And for 4 pounds, that's 8, because 2 times 4 is 8. So that is the domain and range. And we could have any sort of price to some extent and any sort of pounds from 1 to 4 and price from 2 to 8. And that is the notes on the domain and range of continuous functions. The ones that we didn't do, I know I wrote number 4's answer right here and number 3. We'll have to change that up. But the other 2 that we didn't do, those ones I want you to fill out on your own and try out on your own. Make sure, for any reason, if you don't have it already, make sure that this gets glued into your journal.